So today I will solve two exercises. Exercise number 1. As you have seen the exercise number 1, we have f of x equal to, so it's equal to a times x minus h square plus k, where k vertex of the graph of f is at the point P, and point P is 3, 4, and then we have at the same time this graph passes through point Q with the coordinate 1, minus 4. Question number 1 is to write the value of h and k, and the question B, value of a. We know that we have a vertex at this point. That means for the question A, that means that f dash of x, so at this point, so the f dash of 3 is equal to 0. So first of all, I will calculate f dash of x is equal to 2 times a times x minus h. Now we have f dash of 3 is equal to 0, means that 2 times a times 3 minus h is equal to 0, and that means that 3 minus h is equal to 0, means that h is equal to 3. And here we have the first parameter of this function. So with that we can calculate the value of q. So h is equal to 3. So let's see how to do that. Coordinates of p is 3 and 4. Then we will use this information to write down the value of k. So we have p, therefore is part of graph of f. So what we can say that f of 3 is equal to 4. F of 3 is equal to 4. That means that a times x minus h is 3 square plus k is equal to 4. So we have this equation, or we have here that f of 3 is 3 here, 3 minus 3 is 0, so we can find directly that k, 0 plus k equal to 4, then k is equal to 4. B. So what is the value of a? So we have f of 1 is equal to minus 4. So we will use that. That means that 2a times, and then we have f of 1. That means 1 minus h is 3 square plus k is 4 is equal to minus 4. So we have 2a minus 2 square plus 4x2 minus 4. And this equation will give me here, we have here minus 2, here we have a. So we have minus 2 square is 4, so 4a equal to minus 8. This means that a is equal to minus 2. So let's summarize now. So we said that so to find h, we have to really to use the information that vertex of f of the graph of x is at this point. This means that f dash of 3 is equal to 0, and that's this information gave me the value of h is equal to 3. Then I used the second information here another time, that we have our graph passes through P of coordinate 3, 4, and then we have here 3, and 3 minus 3 is 0. So this information that we have used here. So if we have here, which we use information is f of 3 is equal to 4, it will give us that g is equal to 4. Now, for question B, we have that f of 1 is equal to minus 4. That gives us a is equal to minus 2. Okay, that's good. Exercise number 1. So let's go forward for exercise number 2. For exercise number 2, we have f of x is equal to x squared plus 2, and g of x is equal to x minus 3 for x a point of R. So we have to find f of 3 as question A. Question B is to find the here we go to find the composition of g and f of 3, and then we have to find the inverse function of x, and this is what we will do now. So let's start. 3, f of 3 is equal to 3 squared plus 2, it's 9 plus 2 is equal to 11. Question B. For question B, we have to find the composition of g and f of 3. So we know that the composition of g and f of 3 is equal to g of f of 3, and then we have f of 3 is equal to 11, so g of 11. Find is x minus 11 minus 3 is equal to 8, and this is g composition of the is equal to 8. Now the final question C, how to find inverse function of g of x. So we know that function g of g minus inverse of g of x is equal to x, identity function. And here we see now, let's call g minus the inverse of g of x is equal to y. So we have g of y is equal to x, and this means that g of y is y minus 3. Y minus 3 is equal to x. So y is equal to x plus 3. And this is what this exercise number 2 is about. Thank you very much, and see you